All right, so we're looking at the first review, problem number 8. Again, I want to emphasize, kids, this test is over the entire chapter, so we want to make sure that we're not focusing too much energy on any one thing. So, here's the deal. This is the question. It's a sketch, but it has a negative in an unusual place. We need to talk about this. So we know we're supposed to take out that number. So I'm just going to take out the negative, and I'm going to end up with this in graphable form. Okay? Now, her question is, what do I do with that negative right there? Well, there's a couple different ways you can approach it, but the easiest thing to remember is that the sign is an odd function. Now, what does it mean to be an odd function? It means if you put a negative in, you get a negative out. So an example of an odd function is this. If you put in positive 2, you get 8. If you put in negative 2, you get negative 8. So the sign of the input impacts the output. As opposed to an even function, put in a 2, you get a 4. Put in a negative 2, and you still get a 4. So in an even function, the sign of the input has no impact on the output. But in an odd function, if you change the sign on the input, you're going to change the sign on the output. So basically what that means is, if you take f of a negative, and that's what we're doing right here, or f is our sign, we're taking the sign of a negative. When you take f of a negative, and the function is even, you can basically just erase the negative, because it's not going to have any input, or any impact. If the function is odd, though, if you stick in a negative, you are going to get out a negative. So since this is an odd function, sign is odd. I'm going to tell you what they all are in a minute. What is 0 and 1? Sign is odd. I'm going to take that negative and pull it out here. Because when the negative is out here, I know exactly what to do with it. Right? Now, a negative inside, a negative on the x, is a reflection across the y-axis. So you can approach the problem from that standpoint, but sometimes with trigonometry, it's a little bit trickier to reflect this way than it is to reflect this way. I like to go upside down. That's easy for me. But you can also reflect sideways, if that's what you wish to do. That's what's happening in this problem. If you take the sign of a negative, you can pull the negative out in front. If you have a tangent, a cosecant, or a cotangent, you treat them all the same way. The only functions that are even are secant and cosine. And if you remember your graphs, that makes sense. This is a cosine, right? And what does it mean to be even? It means you are reflected across the y-axis. So if this had been a cosine problem, I would just erase that negative. But since it's a sign, I have to pull it out in front. So in the big scheme of stuff to know, this is one of those details that determines the A++ from the A+. This is not something to lose sleep over. The only functions that you can drop the negative, if you're graphing, the only functions that you can drop the negative are cosine and secant. Any other function, just pull it out in front and graph it like that. Okay? Test?
So the even function is just reflected across the y-axis,
Yep. Origin. Okay, all right, so that takes care of that. So if we have that inside negative, if it's a cosine or a secant, we're gonna drop it. If it's anything else, we're gonna bring it out in front. Okay, Maren? And not lose any sleep over it. All right, Leah?
Can you do number 8 from homework 4.8?
All right, I want to alternate back and forth between homework and review sheets because again, the test is over the whole chapter. All right, so I'm looking at problem number 8 on the homework. All right. So here's Fort Lauderdale, and I'm on a course of 65 degrees. So this is 65, and I'm going 40 miles an hour for 2 hours. So this is 80. Then I change a course to 155. So 155 would be like here. And I go for 40 miles an hour for 4 hours, so I'm going 160. No, I ain't going miles. Determine the distance and the bearing from Fort Lauderdale to the boat. So remember, this was Fort Lauderdale. This is my boat. So I want to find that distance, and I want to find this blue angle right here. That's my job. Now, the blue angle will just be 65 plus this one, right? So I'm going to have to find the angle inside my triangle. Let's find some more angles here. If that's, let's see, if that's 155, this guy right here, this little piece right here is 25. If that's 65, then this is 65. And here's that magical moment. That is a right triangle. So to find the blue side, I could just do the Pythagorean theorem. And some of you did it exactly, and that's fine. I'm going to go ahead and just write down 178.89 nautical miles. Remember, knots are nautical miles per hour. So our unit is nautical miles. Okay. Now, I need this angle right here. I'll call it theta. That's a right triangle. So can I say, excuse me, tan theta equals 160 over 80? Opposite over adjacent. And so theta is going to be the angle whose tangent is basically 160 over 80. So theta will be second tangent 2, 63.43. So the blue course, remember we always measure from due north, so to get down to this blue line, it's going to be 128.43. Did I do that right?
Yeah.
That's going to be my answer. Okay?
So when you change the course to 155 degrees, why would it be going like to the right instead of to the left?
Okay. Go wherever I am, I set up a compass, and I plot for that point.
Yeah, but wouldn't 155 be like in quadrant?
Navigational angles are measured like this.
Can we leave that an angle, or does it have to be like the bearing?
No, that's it, right there. That's it. Okay, Lucy?
I figured it out.
Okay, Tess?
Oh,
All right. Lillian?
Can you do number 3 from 4.8?
Okay, first I'm gonna do one from the review sheet. I wanna alternate back and forth. So anybody spend any time with your review sheet, either one, just tell us which one, and have a question about it. Okay, Sam,
16 on review sheet 1. I figured out the degrees, but I forgot to do like the degrees in minute and second.
review sheet 1, number 16. So I'm changing 3 radians, so pi is 180, as 3 is to x. So when I solve this, alright, this would be called the exact degrees. That's the exact answer. Okay? So that would be C. That's the exact degree value right there. Now, what is that decimally? Well, 540 divided by pi. So decimally, it's 171.887 degrees. That would be the decimal value of this fraction. And then degrees, minutes, seconds. I'm just gonna take that number that I just got. I'm gonna second angle, DMS it, and it's 171 degrees, 53 minutes, and 14.419 seconds. Does that make sense?
Yep.
All right. Okay, now, Lillian, what was your question?
Number 3.
On,
4.8.
all right, so here we go. All right, so bearings of 2 points on the shore from a boat are 115 and 123. Assume the 2 points are 855 feet apart. How far is the boat from the nearest point on shore? Okay, so let's put our boat right here. And he's looking over here on the shore. There's the shore. And he's looking at a point, and his angle is 115 degrees. So there's my first point. And then he's looking at another point, and that one is 123 degrees. And the 2 points are 85.5 feet apart. Or no, 855 feet apart. All right, how far is the boat from the nearest point on shore? So that basically would be this, right? That's what I'm looking for. So, let's see, we got a couple of right triangles going here. We got this little skinny one here at the top. That angle, remember, that was formed by 115 degrees. So this angle is 25, what would that be? 90, is that 25? And then this one is 123. So the bigger right triangle, that's a 33 degree angle. I have no idea what this distance is, so I'll just call it y or something. But I can build a couple of equations now. I can say the tangent of 25 is y over x, and the tangent of 33 is y plus 855 over x. Does that look okay to everybody? Yes?
Wait, how did you get 25 and 33?
This is 90. So 150, this whole thing's 115, so I went 90 plus 25 to get 115. I subtracted, right? Alright, so now I've got two equations, two unknowns, and I have to solve for something. So you will solve for whatever you want. Just make sure that in the end, you get the answer is going to be X. That's what we're looking for. So, now that I'm looking at this, I wonder, can I just take this and substitute it in right here? So X tan 33 equals X tan 25 plus 855? Will that work?
Wait, I'm confused. Why would you solve for X? I thought you're solving for like the two hypotenuse lines.
How far is the boat from the nearest point on shore?
I thought it would just have to be like.
How far is
Yeah,
the
that
boat?
it doesn't make sense. Yeah.
This is clear, that's X. There's no question about that, that's X. Alright, so I have my two equations. Since this is what y equals, I'm just putting it in right there. Now I have x's. I'm solving for x. That's good. So I'll put them on the same side of the equation. Factor them out. And divide. Right? Alright, let's type it in and see what happens. I got 4669.58. Miles. Feet. All right, Lillian, how's that look?
Well, I did that, but I still didn't get the right answer.
I don't know, we'll have to look at it and see. If you understand this, we're good. I don't know why you're not getting the right answer. Are you setting degrees?
Oh,
Is this exactly what you have right here?
On there, yeah.
All right, type tan 33 minus tan 25. Make sure you close your parentheses. Then do 855 divided by second answer.
Okay, I got that.
Got this? So something about the way you're typing it in was wrong, so just do it that way next time. All right.
could we do another one on homework?
Nope, we're alternating.
Oh, okay.
We are not obsessed with this one homework assignment. We have got to look at the whole chapter. So who found something else on the review sheet?
28.
This is review 1.
Review
20D. All right, airplane leaves the airport at a course of 320. All right, so here's my airport. 320 would be over this way. So that's 320 degrees. At a speed of 450 miles an hour after traveling 30 minutes. So this is 225. Now he's here. He changes to a course of 230. So 230 would be like here. And flies for an hour. So that one is 450. And now he's here. What is the plane's bearing and distance from the airport? So here's the airport. Here's where I'm ending up. So let's see if our little magic works up here. Okay, let's figure this out. If that's 230, then this guy right here, this angle right here, would have to be 50. Does that make sense to you? And if this is 320, then this guy right here has to be 50, because that's 270 and 50 more. And if that's 50, then this is 40. And if that's 40, this is 40 because of alternate interior, and there is your 90. So we'll do the Pythagorean theorem. This is just like the one we did a little bit ago. We'll do the Pythagorean theorem to find the distance. And it's 503.12 miles. Now, Liam, I need his direction, so I need this orange angle right here. Well, I know that this big black is 320. So if I could find this angle, then wouldn't the bearing be 320 minus that? So I'm gonna find that angle, I'll call it theta. And just like before, since this is a right triangle, tan theta equals 4, actually, it looks like it's gonna be the same angle. So theta is the angle whose tangent is 450 over 225. And this time I'm gonna subtract that to get down to the blue line.
Well, this is 60.
So I got 256.57. 256.57 for the bearing of the airport.
How did you get to
Okay, Liam? Lucy?
I'm really confused on what the 40 and 50 came from.
Okay. First of all, if the whole thing is 360, Lucy, and this much is 320, then that angle right there is 40.
Okay, yeah.
That angle and this angle are alternate interior,
Yeah.
automatically congruent. This angle was 230 degrees, straight down is 180. I went 50 past, so that's 50.
Oh, okay.
So there I got it.
So is the bearing how far from due north to
Yep.
where your hypotenuse is?
Yep. To the final course, whatever the final course is.
And the final course is always our hypotenuse in this.
Well, I hate to say that because they're not always gonna be
But-
right triangles.
But in this.
It's from the starting point to the ending point.
Okay.
So what, for 503.12, did you use Pythagorean theorem for that, or did
Yeah.
you do? Okay, because I was catching up with it, so I just went ahead. I'm not sure what I did wrong.
What did you do?
I tried to. Wait, wouldn't theta, like on the inside of the triangle, be 50 degrees, right?
Where?
No, because
Like
you
where
have
you have
to.
that little orange O.
No.
Why wouldn't that be 50?
Because its tangent is 450 over 225. And the angle whose tangent is 450 over 225 is not 50. Why would it be 50?
I was thinking.
This piece is 50. Because 320 minus 270 is 50, so that little piece is 50. But the whole angle isn't 50. All right, we have to move on. Test.
So what exactly is the bearing?
It's its direction. What direction is he on? What direction is he following?
So it would be all the way around actually.
Always measured from due north. Always measured from due north. All right, that was a review sheet. Anything from the homework still? Maren?
Number 5 on the homework. The co-star. I just couldn't read like the top little stick.
Alright, so Coast Cutter travels at 30 knots from its home port of Corpus Christi on a course of 95 degrees. So here's my compass, so 95 would be like this. This little angle right here is 5 degrees.
Or
On a course of, I'm not sure what this line is, yeah, on a course of 95 for 2 hours. So this length is 60. He's going 30 miles an hour for 2 hours. Then he changes course and does 185. So that's going to be 5 degrees past here. So that's 5 degrees past there. For 2 more hours. So that one is also 60. Find the distance. Okay, so we're doing the same thing we were doing before. So we want to find this right here. So the first thing we're going to do is find the length. Then we got to find this big blue angle. Now, first we got to figure out if we got our magical right triangle in there. Keep in mind that if that's 5, this guy right here is also 5. And if that's 5, this part's 85, because that makes 90 right there. So there it is. There's your right triangle. And not only, I don't even need a calculator for this one, because not only is it a right triangle, but it's
45.
isosceles, which means it's a 45, 45, 90. So this is 45, this is 45, and this will be 60 root 2. Now you can go ahead and get a decimal for that if you want, but that is one of your special triangles. So what's the blue angle? Well, the big blue angle is 185 minus 45?
Yeah.
Or no?
Yes.
No, minus this whole piece would be 50.
Oh, yeah.
So this is 95. And, okay, when I did that in blue, I should have done just this part. The blue part's 45. So 95 plus 45 is 140. So the course is 140. 95 plus 45. Now, we could use the calculator to do that. We didn't need all the more special. All right, review sheets. What's next on the review sheet? Which one? On review sheet 1?
Yes.
17 on review sheet 1 says find x, and x has to be between 0 and 2 pi. So in terms of a picture, where does x have to be in terms of my quadrants here? It has to be here or here, right? Now, actually, isn't the sign going to be negative in both of those spots? So I'm actually going to get 2 answers to this problem because both quadrants, both eligible quadrants, fit the problem. So I just need to find out what my reference angle is. That is not a special triangle. Set my calculator in radians, because that's what this tells me right here. That says we're working in radians. So I'm in radians. I'm going to second sine 1/3. Whoops. Second sine 1/3 and this is about 0.34. Would you agree with that? My reference angle? Second sine, 1/3. All right, so then what are the answers? Well, the answers are this angle
Pi plus
and this angle. So how do I get the orange one?
pi plus 0.3.
Pi plus 0.34. And how do I get the blue one? 2 pi minus 0.34. So whatever those are the answers to the question. All right, Catherine?
When you take like the inverse sign of the negative number, do you make it positive?
I never put the negative in because I just need the reference angle. The negative's already accounted for by the picture, so I just don't put the negative in. If you do put the negative in, the cosine's gonna give you problems, so you really have to be on your toes if you're gonna put the negatives in. Leah?
So whatever our domain is set in is what our answer should be?
Yep. Lillian?
I'm confused like why you're solving for that angle.
Why what?
Why you're solving for that angle? Like the one. Like is that what X is?
What angle would you wanna solve for?
I don't know. Like, or I just don't know why.
Well, I need an angle that's between pi and 2 pi, so it has to be down here. Because this is pi and this is 2 pi, right? The 180 and 360. So I need the angles in standard position. They gotta start measurement here and end up in quadrant 3. I mean, yeah, I don't know. I mean, there are 4 angles that have a sine of 1/3. But these two don't count because I need it to be negative 1/3. So it's these two down here. It's the angle of the origin. So 180 plus this one, 360 minus that one. Always. All right, now homework or review sheet, I don't care at this point. What do we got?
Did you do number 1 of review sheet 2?
Review sheet 2. Number 1. We're evaluating this. I think we did one of these the other day. We're evaluating this with a calculator and without. So I'm going to do it without first. Now, I'm actually in luck because that's a positive number. This inverse notation, this is where you got to remember where the things are defined. But as long as that number is positive, it's always going to be in quadrant 1. It's when it's negative that you got to remember if it's 2 or 4, 2 or 4. But this is quadrant 1. So there's an angle in quadrant 1 whose cotangent is 3/7. This is an angle, and his cotangent is 3/7. So that means his hypotenuse is root 58. So that's a picture of the angle. Now I need to know its cosecant. Well, cosecant is the reciprocal of the sine. So root 58 over 7 is the cosecant of that angle. And now I need to times it by 4. So there is my by hand answer. Now, typing it in on the calculator is a little bit trickier because you don't have any of those buttons. So first thing I would remember is if the angle has a cotangent of 3/7, doesn't it have a tangent of 7/3? That I can type in on my calculator. So I'm going to think of the angle whose cotangent is 3/7, this angle. It's actually the tangent is 7/3. Now, how do I type a cosecant into my calculator? 1 over sine. And then when I get that, I'm just gonna times it by 4. Now, hopefully, these two numbers are the same. 1 divided by sine, second tangent, 7/3, times 4. So decimally, I got 4.35187. Let's see what I get here. 4 square root 58 divided by 7. Same thing, thank God. Right.
Can you just clarify? Not get that. And then typed it.
Can you just clarify the difference between like the cotangent, what the -1 does versus cotangent versus tangent? It's
This
1
notation
divided by
always
instead
means
of
an angle. This means an angle.
Right.
So the angle whose cotangent is 3/7 is the same as the angle whose tangent is
Is
7/3.
Right.
Right.
The difference between cotangent. Okay. The cotangent is 1 over tangent.
Okay, now I'm not finding a cotangent.
Wait, no, I know not in this case.
I'm
in
finding an
general.
angle.
But that is true. And then what is
Yes.
the cotangent of -1?
That is the angle whose cotangent is 3/7. This is an angle. Yeah, this is an angle. So I don't take reciprocals of angles. You never do 1 over 60 degrees. The angle whose cotangent is 3/7 is the same as the angle whose tangent is 7/3. I take reciprocals of sines and cosines. I don't take reciprocals of angles.
So what is the -1?
Tells me it's an angle. This is the notation that says the angle whose cotangent is. This is an angle. Okay.
So when we have like any of these in inverse form in our calculator, like we have to find like the opposite of the inverse form. Like if there was cosecant in the parentheses instead of cotangent, then we would have to find
Change it to a
the
sine. It's the only way you can type it in.
And then when it's not an inverse form, you can use the reciprocal.
Yes. Okay, and what bugs the heck out of me, I don't care what you memorize, but when I was doing this, I was just proceeding through it logically. I don't have anything memorized other than sines, reciprocal, cosecant, stuff like that. But I said, okay, this is an angle. This angle has a cotangent of 3/7. That means its tangent has to be 7/3. I need a cosecant. I didn't find a cosecant. I did 1 over, so I did 1 over the sine of my angle. But memorize whatever you want. Lucy?
Can we do 12? Oh wait, can we do review still?
Yeah, whatever.
Can we do 12 on review number 2?
Review number 2, write 2 equations using different functions. So, okay, so when you see that picture, what 2 functions pop into your head? This is a sine or a cosine. So I've got 4 different adjustments I can make. 4 different adjustments. So I need to fill in all those blanks. Well, it looks to me, right off the bat here, that there's been no vertical shift. Would you agree? And the amplitude of the thing is 1/3. Now, if I look at it as a sine, then probably you will start looking right here, right? Which means the phase shift will be -pi/5, so your sine equation will be x plus pi/5. Now, clearly you could start looking over here You could, I mean, there are other places you could start, but in this problem, it just seems like that's where you would start, your sine curve. If you're looking at it as a cosine, then you might start it here. So that phase shift would be minus pi over 10, if you're looking at it as a cosine. Now we need the period. Well, you ought to be able to figure that out. From negative 1/5 to 1 is how far? 6/5 pi. Now that's the period. That is not the number that goes there. Remember, 2 pi divided by that number gives you your period. That's how you find your period. You take 2 pi and divide it by this coefficient. Right? Now I'm going to solve for n. When I reduce and cancel, I got 5/3. Is that what you got? Yeah. So the number that goes here is 5/3. Remember when you do this, no matter what the functions are, this won't change except sometimes one might be negative, but the number itself won't change. This number won't change, and this number won't change. The only thing that changes is the phase shift, and that's because depending on what curve it is, you're going to be starting in a different place. Okay? Lucy?
Oh, someone else could go. I just asked a question.
Huh?
Someone else could go. I just asked a
Okay,
question.
Kylie?
Can you do 20A on the first one?
On the first review sheet, 20A.
It looks like that.
Jim looks at the top of a building, so here's a building, here's Jim, looking at the top of the building, and the angle of elevation is 35 degrees. He moves 100 feet closer, and now the angle of elevation is 40 degrees. What is the height of the building? Well, since we're restricted at this point to right triangle trigonometry, we better look for a couple right triangles here. Let's call this y. Would you agree that the tangent of 40 equals x over y? And the tangent of 35 equals x over 100 plus y? So now you have a system of equations, and you're going to solve it however you solve it, right? So I'm going to do the fractions first. So y tan 40 equals x, and 100 tan 35 plus y tan 35 equals x. So I cleared my fraction, brought my y over here, brought my 100 plus y, which is a quantity. And now I'm going to go ahead and set them equal to each other. Now I know I'm not going to get what I want. I'm going to have to do a second step, but that's okay. So I just, since they're both equal to x, I just set them equal to each other. Now, what do I need to do to solve this? Get my y's on the same side. And then factor out the y's and divide. So it looks like y is going to equal 100 tan 35 divided by tan 40 minus tan 35. Alright, so See if you can type that in. I gotta go back, make sure you're in degrees, folks. Okay, what did you get for Y? 504? Now, that is not the answer to the question though. That was for Y. So look right here, we're solving for X. We have Y, so what are we gonna do? Multiply it times tan 40, and the height of the building is 423.02 feet. Okay, Kylie?
Thank you.
Don?
On review sheet 2, can you do 4B?
Alright, 4B, on the area that's shaded, okay, this is way easier than you think. The angle is 95 degrees, the radius is 4. What's the area of the whole circle? The whole circle is 16 pi. I don't want the whole circle. I want 95 3/60ths of the whole circle. Do you agree with that? 95 3/60ths? So I'm just gonna take 95, well, if I'm doing it exactly, I'll take 95 3/60ths times 16 pi and reduce my fractions and all that. If I'm doing it with a calculator, I'll just type it in. But that's how I will do it. Okay, so here's the plan. All right, I don't know if we're gonna have school tomorrow or not. Either way, I am totally and completely 100% not convinced you people have a clue what's going on. All right, I'm very, very concerned about